Good evening to all of you. Now we are well familiar with the magnetism. We have also seen about the classification of the materials according to their behavior in the magnetic field. And the classification is that we have seen diamagnetic material, paramagnetic material, ferromagnetic material, antiferromagnetic materials, and ferrimagnetic materials. That all we have seen here. Now let us see about the Biot Savart law. We know that just we have seen in case of electricity, the electric intensity at a point is given by the Coulomb's law. That we have seen in case of electricity, the electric intensity at a point is given by Coulomb's law. Now similarly here, we have to see about the magnetic induction, magnetic field at a point. We know that the current carrying conductor produces the magnetic field. Whenever the current flows through the conductor, it produces the magnetic field around it. That is known to us. Now let us see here, we consider that the conductor and we consider the small current element that we can show here for our convenience with different color. That we can see here like this. Now this is the current length element, suppose that we can consider here. Its length is suppose dl, and this current element produces the magnetic field around it, and we consider here the point P here. Now we can draw the line from center of the element to the point P here. That we can show here some here. And let this angle is to be theta here. This angle is theta in this case. I is the current flowing through this conductor. Length of the element is dl. And let us suppose this point P is at a distance r from the center of this current element here. Then we can say here the magnetic induction produced at point P due to this current element is directly proportional to current flowing through that element. That is, we can write here dB is directly proportional to I. dB, that is magnetic induction produced at point P due to this small current length element. Now, it is also directly proportional to length of the element, that is dl. dl is length of this element, and it is also directly proportional to sine theta. Directly proportional to sine theta. That theta is the angle between current element and the line joining from center of the element to the point P here. Now it is inversely proportional to square of the distance between the current element and the point. That is, we can write here. Or we can write in here in one line as dB is directly proportional to IDL sine theta upon r square. dB is directly proportional to ideal sine theta upon r square. And this is known as Biot Savart law. Here we consider the constant of proportionality as mu 0 upon 4 pi. And therefore we get here dB is equal to mu 0 upon 4 pi ideal sine theta upon r square. And this is known as Biot Savart law, which is used for the determination of magnetic field due to the current element here. Just in case of electricity, we have the Coulomb's law. Here we have Biot Savart law that we can see here this statement तुम्ही लक्षात ठेवायची आहे dB is equal to mu 0 upon 4 pi into ideal sin theta upon r square, which is known as the Biot Savart law, and that can be used for the determination of the magnetic field due to the current. Now we can see its applications there. Magnetic induction due to the long straight wire. Now we can consider here the long straight wire carrying the current I. Here it is the long straight wire carrying the current I in the direction as shown in this figure here. See that. Here this is long straight conducting wire and it carries the current I. This arrow indicates the direction of the current. Current is flowing in upward direction. Now we consider the point P, which is at a perpendicular distance R from O. Point P is at a perpendicular distance R from O. At point P, we have to calculate the magnetic induction here. Now consider the small current length element here, ideal. This is the current element ideal. Now suppose this element is at a distance L from O. This element is at a distance L from O here. Now point P is at a distance R from the current element. And let us suppose here the angle made by this current element and the line joining from center of the element to the point is theta here. That we can see there. Now here from the geometry, this angle is also theta here. Then according to Biot Savart law, we can write magnetic induction at point P is due to this current element is dB is equal to mu 0 upon 4 pi into ideal sin theta upon r square. By using this relation, we can calculate the magnetic induction. Now here, the total magnetic field due to entire wire then, that can be written here as twice the integral, because we see here, this is upper half of this wire and this is lower half of the wire. Upper half of the wire, that length is increases from 0 to infinity here, and again similarly from 0 to infinity in the lower part also. And that's why the total magnetic field due to entire wire is given by B is equal to twice the integral of dB. Integration limit 0 to infinity. Now then, we can put the value of dB then. And that's why we get here dB is equal to twice the integral of mu 0 upon 4 pi ideal sin theta upon r square between the limits 0 to infinity. Now we can take the constants mu 0 upon 4 pi out of this integration, and in bracket we have left integral of ideal sin theta upon r square. Now then, suppose here this is our equation number 2 then. We have r is equal to under root of L square plus r square. If we can see here this in this figure, in this case, r square is equal to L square plus r square. From this figure we can write here. And that's why r is equal to, here r is equal to under root of L square plus r square here. From by using this Pythagoras principle that we can write here. R is equal to under root of L square plus r square. Similarly, we can write sin theta is equal to sine of pi minus theta, and that is equal to r upon r. front side upon hypotenuse. Putting these values in this equation, that is, we can get here B is equal to mu 0 I upon 2 pi. Here with this 2 get cancelled, and in bracket RDL. How we get it? See that sine theta is equal to R upon R. We have put the value of sine theta, that is R upon R. And that's why this R square into R, that becomes R cube. R cube will do that again. And that's why R cube, we know that R is equal to under root of L square plus R square. That can be written as R is equal to L square plus R square bracket raised to half. And that's why R cube is equal to what? L square plus R square bracket raised to 3 by 2. Cube केला आपण त्या ठिकाणी त्याचा. And that's why we get here R cube to the denominator, and here is R. ही टर्म आली लक्षात. R आपण परत बाहेर काढून देऊ शकतो इथे, because it is constant, and that's why mu 0 I into R upon 2 pi integral dl upon L square plus R square bracket raised to 3 by 2. Now we can solve this integral. See that B is equal to mu 0 I R upon 2 pi. If we solve this integral, see that this is equation number 5. And the integral we have to solve here from figure, L is equal to R tan theta. That is, we have the figure like this. Here this is R. This angle is theta, as this is theta. And here we have considered the distance of the element from O is L. And that's why from this figure, tan theta is equal to L upon R. Front side divided by adjacent side, tan theta. Therefore, L is equal to R tan theta. Hence, dl is equal to R in differentiation of tan theta, that is sec square theta d theta. dl ची value घेतली. And now then see that we can solve this term. L is equal to R tan theta. That's why we get here R square tan square theta, R square tan square theta plus R square. We can solve this term. We can take the common factor R square, and in bracket what we have left, tan square theta plus 1. That is, we write here 1 plus tan square theta. And this bracket again raised to 3 by 2. Now we can solve this bracket again then, and we get R square raised to 3 by 2. That we get R cube. R cube in bracket 1 plus tan square theta raised to 3 by 2. And that we can put here these values. And integration limits are also changes, because we have changes L. Integration limit changes from here 0 to finally then pi by 2. 0 to pi by 2. That we write here this equation. Integral 0 to infinity dl upon L square plus R square bracket raised to 3 by 2 is equal to integral of 0 to pi by 2 R sec square theta upon R cube in bracket 1 plus tan square theta bracket raised to 3 by 2. That we have solved here this equation. इथे आपण त्याचं सोल्युशन पाहिलेलं आहे. समजली ही टर्म तुम्हाला? डू यू गेट दिस? तुम्ही डायरेक्टली लिहिलं याचे आन्सर तरी चालू शकेल. इंटिग्रल ऑफ dl अपॉन l square plus r square bracket raised to 3/2. You can directly put here it as जे का फायनल आन्सर येईल आपलं ते लिहून टाकायचं तुम्ही. And that is, we can solve this, and finally we get here at like this: 1 upon r square integral 0 to pi by 2 cos theta d theta, and you know the integral of cos theta, that is sin theta, and hence we get 1 upon r square into sin theta between the limit 0 to pi by 2. Now, finally we can solve this. मग आपल्याला सोल्यूशन sin pi by 2 काय येतो? What is sin pi by 2? Sin pi by 2. Sin pi by 2 is 1 and sin 0, 0. And that's why finally we get 1 upon r square. That we put this value in our equation number 5. And that's why we get here B is equal to mu 0 I r upon 2 pi into 1 upon r square. Here one of the r is get cancelled, and that's why finally we get mu 0 I upon 2 pi r. This is the expression for magnetic induction at a point due to the long straight conductor. Magnetic induction, suppose here we have the conductor, long straight conductor that we can show you. At any point, that suppose this point P is at a distance r from this wire, perpendicular distance r, sorry, capital R घेतला आपण, and then we get here it is equal to B is equal to mu 0 I upon 2 pi r. This is the expression for magnetic induction due to a long straight conductor. Now we can see then magnetic induction due to the circular coil. Expression समजलं तुम्हाला? Magnetic field due to a circular coil that we can see. Magnetic field due to a circular coil. And we have to find the magnetic induction on the axis of the coil. That is on the axis of the coil. Consider here this is the circular coil. This is the circular coil, and it carrying the current I, as we have seen earlier. Its radius is A, that we can see here. Consider the circular coil of radius A here. Now we can consider here this is the axis of this coil that we can represent here. This is axis of the coil. Consider the small current length element here. Consider this small current length element that we can show here by pink line. दिसतोय तुम्हाला या ठिकाणी? This is the small current length element here, and we have to find here the magnetic induction at point P, that is on the axis of the coil. This is circular coil. Now then, this point P is at a distance r from this current element. Now let us see here I be the current flowing here in this circular coil, and that's why this current length element ideal produce
ऑनलाइन
induction.
ऑनलाइन ये क्या है, देखना सर, देख रहे हैं ऑनलाइन चालू है बेटा, ये देख रहे हैं देखो नीचे, ये रहा बड़ा हूँ
produces magnetic induction at point P. This magnetic induction, suppose dB, that we considered here, this magnetic induction
वहां पे सब दिखे हैं उनको मूवी क्या है तो
is to be dB here. That dB is according to
ये जनता की कहने देख रहे थे कि दिखाते देख, ये सारे देख दिख रहा है, देख इधर आओ ना,
म्यूट करा कोणाचा तरी आवाज येतो याच्यावरती. Yes. Now here the magnetic induction at point P due to this current length element, that is given by dB vector is equal to mu 0 upon 4 pi, this is constant, I into dl vector cross r vector upon rq. Now here the magnitude of this will becomes dl into r into sine theta, and that divided by r cube, and that's why here we have r square. When we consider the magnitude, we can write like this. This is the vector form. Now this magnetic induction can be divided into two parts. One of them is vertical part or perpendicular to the axis, that we can designate it as dB perpendicular. Another part is dB parallel or along the axis. dB parallel म्हणू आपण किंवा along the axis. That is, this dB can be resolved into two parts, that is dB perpendicular and dB parallel. That is, dB is made up of these two magnetic induction, म्हणजे या दोघांचा रिझल्टंट हा dB असेल. याला लक्षात बघा, हा dB म्हणजे काय, magnetic induction due to this small current length. We can see it can be resolved into two components, dB perpendicular and dB parallel. Now see here, this line, that is line joining from the element to the point P, makes an angle theta with the axis. It makes an angle theta with the axis here, that we can show you. Now these dB perpendicular components can get cancelled overall, because just we have seen here, we have the current length element. Similarly, we have another current length element. The dB perpendicular produced by these elements are, suppose that we can designate by this line. The dB perpendicular produced by this another current length element are in this direction. They are equal and opposite, and therefore they cancel each other. Similarly, we consider here this current length element, this current length element, and therefore, as we can say here, this circular loop can be divided into even number of current loop elements, and that's why all the perpendicular components get cancelled. And that's why the resultant magnetic induction at point P is only due to what? बघा, या ठिकाणी सर्व परपेंडिक्युलर कंपोनंट्स जे काय मॅग्नेटिक इंडक्शन असेल दॅट गेट कॅन्सल्ड. मग फक्त राहिले कोणते कंपोनंट्स? पॅरलल कंपोनंट्स राहिलेत फक्त या ठिकाणी. these parallel components have the same direction and therefore they can be added here. And therefore, the resultant magnetic induction at this point P due to this circular loop is integral of dB parallel. These are parallel components. dB parallel means, now see in this figure there. Here the components like this. dB parallel means dB sine theta. If we divide or resolve this, then see that this angle from the geometry is theta. Again we get here this angle theta. And that's why here we get dB sine theta. Because sine theta is equal to front side upon hypotenuse here. And we can write front side as dB parallel upon dB. And that's why we get here dB sine theta. Integral of dB sine theta. Therefore, B is equal to mu 0 upon 4 pi integral of dB parallel ideal sine theta upon r square. We have put the value of sine theta. Sine theta is equal to A upon r. And therefore, we get here B is equal to mu 0 I sine theta as sine theta ची value A upon r. Sine theta as A upon r. And therefore here A also taken out of integration. And therefore mu 0 I A upon 4 pi r cube. These are and these are square. The term समजते हैं का solve करो या ठिकाणी. That we write here B is equal to mu 0 upon 4 pi integral of I dl sine theta is A upon r and this r square. And therefore this becomes r cube. R square into r, that is r cube, that goes out. IA in bracket, in integration we have left only dl. Now see here we have the circular loop of radius A. Of radius A. Then integral of dl means total length. मग ही टोटल लेंथ किती येईल सांगा बरं. टोटल लेंथ आपल्याला किती मिळेल. टोटल लेंथ इज हाऊ मच. बघा सर्क्युलर कॉइल आहे. या सर्क्युलर कॉइलची रेडियस ए आहे. त्याची टोटल लेंथ किती येईल. दिसतोय तुम्हाला स्क्रीनवरती. येस ऑर नो.
हो.
मग सांगा या सर्कलची टोटल लेंथ किती आहे.
90 डिग्री.
नाही लेंथ. हे बघा हे सर्कल आहे या ठिकाणी. परत दाखवतो मी. या सर्कलची रेडियस ए आहे. तर याची टोटल लेंथ आपण किती घेतो. Total length of the circle, that is nothing but circumference. That is nothing but circumference. Circumference असतो की नाही तो. म्हणून आपण इथे लिहू या ठिकाणी. That is equal to mu 0 I A upon 4 pi r cube. Mu 0 I A upon 4 pi r cube. आता इंटिग्रल डीएल म्हणजे सर्कम्फरन्स म्हणजे किती आला. दॅट इज 2 pi a. 2 pi a. And that's why we write here 2 pi a. इंटिग्रल डीएल ची व्हॅल्यू टाकली आपण या ठिकाणी. पाय गेट कॅन्सल. 2 2 जा 2r क्यूब झाला इथे. I म्यू 0 IA स्क्वेअर होईल तो न्यूमरेटरला आणि डिनॉमिनेटरला 2r क्यूब. That is we write here b mu 0 I upon 2 in bracket a square upon r. But we have seen here from this figure r square is equal to r. r क्यूब आहे बघा आता या ठिकाणी. हा पॉइंट पी आपण x डिस्टन्स घेऊन घेऊ. This point P is at a distance x from the center. Therefore, R is equal to under root of a square plus x square. So R is equal to a square plus x square bracket raised to half. And therefore, R cube is equal to a square plus x square bracket raised to 3 by 2. And therefore, we can write here in this case final equation that we get here, B is equal to magnetic induction on the axis, magnetic induction on the axis of the circular coil that we have to write. B is equal to mu 0 I upon 2 into a square upon r क्यूब ची व्हॅल्यू काय टाकता येईल मग आपल्याला a square plus x square bracket raised to 3 by 2. Now here, this is the result. Magnetic induction on the axis of the circular coil. That is B is equal to mu 0 I upon 2 into a square upon a square plus x square bracket raised to 3 by 2. Here A is what? What does A represents? A काय represent करतो या ठिकाणी?
Radius.
Yes. A is
Radius.
radius. बरोबर, right. Good. Radius. X distance of the point P. Distance of the point P from the center O. I काय रिप्रेझेंट करतो या ठिकाणी? I काय असतो? I is the, what is I? What is I? I represents the I काय represent करतो सांगा? Very simple. I represents current. आलं लक्षात? आणि मॅग्नेटिक इंडक्शन ड्यू टू द लॉंग स्ट्रेट वायर, त्याचा फॉर्म्युला काय मिळाला आपल्याला? हा लॉंग स्ट्रेट वायरचा फॉर्म्युला B is equal to mu 0
I upon 2.
2 pi r. हा इथे कॅपिटल R घेतलाय आपण. कॅपिटल R म्हणजे काय? डिस्टन्स ऑफ द पॉइंट P फ्रॉम दी कंडक्टर. हे फॉर्म्युला लक्षात ठेवा चांगले. हा लॉंग स्ट्रेट कंडक्टरचा फॉर्म्युला आहे आणि इथे हा सर्क्युलर कॉइलचा फॉर्म्युला मिळाला आपल्याला या ठिकाणी. परत एक वेळेस तुम्ही रिवाइज करून बघा हे डेरिव्हेशन्स. तुम्हाला जर आवश्यकता असेल तर वाटल्यास हा व्हिडिओ टाकून देईल मी, इफ यू रिक्वायर. काही अडचण आजच्या टॉपिक मध्ये नाही समजला असा पॉइंट कोणता आहे? Have you any difficulty in today's lecture? आणि बाकीच्यांनाही सांगा जॉईन व्हायला, कारण जरी आता ऑनलाईन लेक्चर असले तरी प्रेझेंटी तुमची काउंट होते बघा. तुमचे तुम्ही मला हे पाठवतात प्रत्येक वेळेस. जर आता 2 विद्यार्थ्यांनी पाठवलं म्हणजे सर्वांचे नाव येऊन जातील त्याच्यामध्ये. आलं लक्षात? कारण काही वेळेला ते पूर्ण नाव येत नाही. मी प्रयत्न करतो त्याच्यात पूर्ण घ्यायचं आणि बाकीच्यांनाही प्रेझेंट राहायला सांगा, तुमचे मित्र वगैरे जे कोणी असतील त्यांना. आलं लक्षात? ठीक आहे ना, वी स्टॉप हियर. यस, हा बोला.
सर आमची एक्झाम केव्हा होणार आहे?
एक्झाम शक्यतो मे किंवा जून मध्ये होईल. जून मध्ये होईल भाऊ.
ओके.
आता तुमचे
आणि एक्झाम फॉर्म भरायची लास्ट डेट काय सर?
काय
एक्झाम फॉर्म भरायची लास्ट डेट?
ते ग्रुपवर टाकलेलं आहे ना ईश्वर पाटील सरांनी.
पण त्यांनी लास्ट डेट नाही टाकली.
लास्ट डेट नाही टाकलेली का?
हो.
लवकर भरून घ्या ना, काय त्याच्यामध्ये. मी पण नाही पाहिली, ते फक्त मी पाहिलं ते टाकलेलं आहे. किंवा त्यांचा नंबर असेल ना तुमच्याकडे, त्यांना विचारून घ्या मग.
ओके
त्याच्यावर
सर.
दिलेला असेल नंबर सरांनी. ईश्वर पाटील ते कॉम्प्युटरचं काम बघतात ना ते सर्व.
हो सर.